Mysterious unparticles may be pushing the universe apart, new theoretical study suggests. New theoretical research suggests that a mysterious form of matter called unparticles could be the driving force behind the expansion of our universe. The ever-accelerating expansion of the universe may be driven by a mysterious form of matter called unparticles, which do not obey the standard model of particle physics, a new theoretical paper suggests. And I did post a video concerning something like this the other day. I think they estimated that the universe is expanding at 73 kilometers a second. Can you imagine how fast it's expanding? Now, scientists widely acknowledge that the universe is expanding, though the cause of that expansion remains elusive. They don't know why it's expanding instead of staying the same or decreasing, slowing down. One of the most popular proposed explanations is a mysterious entity called dark energy in the form of a cosmological constant, which leads to expanding at a rate independent of the age of the universe and the temperature of matter and radiation. However, recent astronomical observations challenge this hypothesis, prompting physicists to explore alternatives to what dark energy could be. And now, in a new paper, researchers analyzed the idea that dark energy is instead made of a theoretical form of matter called unparticles. They found that this theory aligns better with observations than the prevalent standard cosmological model, which assumes a cosmological constant. Observational discrepancies arise in the values of the universe expansion rate and growth of large-scale structures, galaxies and galactic clusters. Between measurements, study co-author Utkarsh Kumar, cosmologist at Ariel University, said, various observations, including cosmic microwave background measurements, dimming of supernova, and many others, contribute to this tension. Quantities such as the Hubble constant, which determines the rate of expansion, and the so-called S8, which contains information about the formation of large-scale structures, are not measured directly. Instead, they are calculated from observations of the cosmic microwave background leftover radiation from the Big Bang and distant stars and galaxies using mathematical theories. But different theories yield different values of these parameters from the same data, posing a huge tension in cosmology. To address the problem, the authors of a new study published in December 2023, the Journal of Cosmology and Astroparticle Physics, suggested that the expansion of the universe is driven not by a cosmological constant, but by unparticles, which had previously been considered in the context of particle physics. The idea of unparticles was introduced by theoretical physicist Howard Gheorghi over a decade ago. Lead author said Ido Ben Dayan, also of Ariel University. In fundamental physics, we usually discuss fields like the electric field, where particles are excitations of the field. In the electric field case, these are the photons or packets of light. In almost all cases, Ben Dayan added, particles are excitations with a well-defined mass and momentum. But unparticles are the result of a set of fields that their excitations do not have a well-defined momentum and mass, and thus, at the microscopic level, they behave as a fluid. A special outcome of this property is that their equation of state describing the ratio between the pressure they exert and their energy density depends on temperature. This equation of state strongly resembles the equation of the cosmological constant, and moreover, the very weak interaction of unparticles with regular matter, which is predicted by all theoretical models of the substance, makes it an excellent candidate for dark energy. Unparticles Untangled. In their work, Ben Dayan and Kumar used the unparticle hypothesis instead of the cosmological constant and combined it with observational data collected from many experiments. They found that unlike the values calculated using the standard cosmological model, the values of the Hubble constant and the S8 parameter deduced from these experiments were consistent with each other when they used the unparticle theory. And moreover, their model reduced the discrepancy between the measurements of the Hubble constant and S8, thus restoring the agreement between the different measurements, Kumar said. For now, there's no empirical evidence to back up this theory, but the authors are confident that in the next decade or so, the accuracy of astronomical measurements will improve enough to determine whether the unparticle theory is correct. Our model is tested by constantly improving cosmological observations, Ben Dayan said, and if it's correct, future cosmic microwave background experiments should confirm it. Experiments to measure the nature of dark energy are currently being developed, but will require telescopes to probe further back in time than they currently do, Ben Dayan added. Moreover, the physicists plan to increase the accuracy of their calculations and look for possible manifestations of particles in more familiar experiments with elementary particles in accelerators, which could be affected by the presence of unparticles. We plan to consider interactions between unparticles and the standard model of elementary particles, Kumar said, and this can further test our model. We will further study some extensions of our model and their cosmological consequences, he said. This is by Andre Feldman on Life Science. Please leave your comments and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.